Okay, so now we have the Simkin hardware store, and the demand frequency distribution is right here. Okay, from we saw that in the PowerPoint file, say like from here. So we do a sum of this, and then relative frequency will be frequency divided by the total, and you have to absolute reference that and copy, and that will give us the individual probabilities, a relative frequency, and the cumulative probability is you sum that with itself, except that the first one, D9, should be made into absolute reference. Then when we copy, we get a cumulative probability distribution ending with 1. Okay, let's put the border back. So then the demand distribution is going to be, okay, the VLOOKUP table. Okay, so these are the demands, and the lower limit for VLOOKUP table, the lower limit starts with 0, and it is the cumulative probability of the previous row. Okay, so now we have the VLOOKUP table, and we can set up the demand based on that. So we have the model here. Okay, so if you want demand, the first row is blank because of initial conditions. We will get to that, but now we are ready to set up the demand. So we look up rand, and then the lookup table, and that should be absolute referenced, comma 2. So that will give us the demand for each day. And say we want to simulate 10 days, and then we'll replicate it after that. Okay, so here are the demands. All right. So now the second variable that is that we need to simulate is the lead time if an order is placed. Okay, again we use the same structure as before, and remember this can very well be some other distribution instead of a discrete distribution like this. So compute the probability, okay, F4. All right. Copy that, and then you have the sum of that D19 to D19, except that the first D19 should be absolute referenced. Then we get a cumulative probability distribution. Okay, let's put the border back, and the lead time is 1 to 3. Okay, and 0, and the cumulative probability from previous row is the lower limit for the VLOOKUP table. Okay, so that's our lead time. But we can't simply use the VLOOKUP table in the lead time for outstanding order, because lead time is relevant only if we place an order. So we have to first figure out whether we need to place an order or not. Okay, so for that we need to look at the inventories. Okay, so beginning inventory, okay, so we have our initial policies. So this is 10 and say 5 is the reorder point. So that's our decision variable. Okay, let's color code that yellow. So that's what we were trying to decide. The beginning inventory of 10 units on hand, that is given input. So let's do it like that. So beginning inventory is for the first day is that. Okay. Okay. Now ending inventory then is beginning inventory minus demand. Okay. Except that if demand was like 20, you cannot have negative ending inventory, so it has to be 0. So what we really need is max of 0 or the beginning inventory of the day, okay, minus the demand. Okay. So now if the beginning inventory is smaller than demand, then ending inventory will be 0. Okay. Then lost sales will be, again, if it is demand minus beginning inventory, if it is positive, that is, in this case there is no lost sale. So 5 minus 10, okay, but only if it is a positive number. Right? So if demand is greater than beginning inventory, then the difference is lost sales. Otherwise, there is no lost sales. So that would be max of either 0 or demand minus the available inventory. Okay. Okay, now the rest of the model is going to be tricky. So that's the reason why I took this up last. Okay, so we need to set these columns up very carefully, and this can be done in more than one way. This is not really anything to do with simulation, but it's actually to do with, that is, setting up these columns is more to do with Excel modeling than Monte Carlo simulation itself. Monte Carlo simulation is right here, how you simulate random numbers from specific probability distributions, either discrete or any defined distributions like normal or exponential or Poisson or binomial. Okay.